Okay, in this video I'm going to be going over how to solve a couple other types of equations. So just as a reminder, for the last 2 weeks we've been working on solving quadratics, or equations where the largest power is 2. So now we want to start to solve some equations that are a little bit different from these. And so we're going to talk about 2 different types of equations to solve today. The first is absolute value equations, and so this should mostly be a review from your Algebra 2 class for how to solve absolute value equations, but we're going to start with a pretty simple problem and then head to some more complicated ones. So if I know that the absolute value of x is equal to 5, I'm going to take a look at my number line for the different values that x could be. So I could substitute in 2 different values for x to get 5 as my answer. So x could be a positive 5, because the absolute value of positive 5 is equal to 5. Or x could be a negative 5, because the absolute value of negative 5 is equal to 5. So really, with absolute value equations, I'm looking at the distance of my solution from 0. So the distance from negative 5 to 0 is 5, and the distance from a positive 5 to 0 is also 5. So with absolute values, I'm focusing on the distance from 0. Let's look at a slightly more complicated problem. So if I've got the absolute value of x plus 9 is equal to 20, well, when I was solving this problem, I could easily see what I could plug in for x to get a positive 5 out of my absolute value equation. Now it's not so easy because I've got a 9 here. So when you're solving absolute value equations where the answer is not obvious to you, you're going to set up 2 different equations. So your first equation, you're simply going to just drop the absolute value signs and rewrite the equation. So I've got x plus 9 equals 20. Nothing changes. In my second equation, I've got to account for the fact that my answer could actually be a negative 20, that my distance from 0 to 20 is 20, and my distance from 0 to negative 20 is also 20. So I'm going to take whatever's in my absolute value sign, that's going to stay exactly the same. So I'm still going to have an x plus 9. But whatever's on the other side of my equation, so this 20, now becomes a negative. So I've got x plus 9 equals negative 20. I've got these 2 equations. Now I'm just going to solve, subtract 9 from both sides. 20 minus 9, that's going to give me x is equal to 11. So that's one solution. If I subtract 9 from both sides over here, I'll get x is equal to a negative 29, and that will be one solution. So I should have 2 solutions every time to my absolute value equations, at the least. Let's try another one. So I've got the absolute value of x plus 4 equals 5x minus 2. Make a prediction. How am I going to solve this equation algebraically? What am I going to do? Okay, well, hopefully you got at least one of the equations. One of my equations, I'm just dropping the absolute values. So I'll have x plus 4 equals 5x minus 2. I've got to have a second equation. My absolute value stays the same, so I've got x plus 4 equals, but then whatever is on the right-hand side of my equation, this 5x minus 2, that has to become negative. Since I want that whole side to become negative, I'm going to put whatever is on this left-hand side, this right-hand side, into parentheses. So I've got a negative, and then in parentheses I'm going to put 5x minus 2. Let's go through and solve this one first. Find a solution for x. What will it be? So you should have subtracted x. So I've got 4 equals 4x minus 2. If I add 2 to both sides, I'll get 6 equals 4x. And now my last step is to divide by 4. So x equals 6 over 4, or 3 over 2. And that will be one of my solutions. Now if I look over here, in order to solve this, my first thing that I've got to do is to distribute in that negative. So I'll have x plus 4 equals negative 5x. And then a negative times a negative 2 is going to give me plus a 2. Now I'm just going to go through and solve. So I could add 5x to both sides, so that I've got 6x plus 4 equals 2. Then I can subtract 4, so that I've got 6x equals negative 2. Divide by 6. I get x equals negative 2 over 6, which will simplify down to a negative 1/3. And so my two solutions should be 3/2 and negative 1/3. We're going to come back to how to solve this graphically in just a moment. Last one. So now this should look a little bit different. I've got a quadratic equation inside of my absolute value. So make a prediction. What are my two equations for this going to look like? Okay, hopefully you got that the first one, I'm just going to drop the absolute values, everything else stays the same. So x squared plus 4x minus 3 equals 2. And for the second one, I'm going to drop the absolute values, so x squared plus 4x minus 3 equals, and now my sign on the right-hand side is going to change, a negative 2. Now I'm just going to go through and solve these two quadratic equations. So in order to get solutions, I'll go through this first one and then you'll try the next one. I'm going to subtract 2 from both sides so that I get my equation equal to 0. So now I've got x squared plus 4x minus 5 equals 0. At this point, you may see that this is going to factor out, or you can use the quadratic formula if you cannot factor. So I can factor this out though, so I'm going to use Snowflake. My coefficient for x squared is just 1. I'm multiplying 1 times negative 5 to a negative 5, and I'm adding to a positive 4. My two factors are going to be a positive 5 and a negative 1. So my binomials are going to be x plus 5 and x minus 1 equals 0. So when I set each of those pieces equal to 0, equals 0, equals 0, I'll get x equals negative 5 and x equals 1. Go ahead and solve this second quadratic. What are your two solutions to this quadratic equation going to be? Through and solve this, you should have noticed that you're going to need to use the quadratic formula. This is not going to factor out nicely. So I end up with x equals negative 4, that's my b value, plus or minus the square root of 4 squared minus 4 times 1, which is a, times negative 1, which is c, all over 2. Then I'm going to simplify what's inside of my square root. So I end up at negative 4 plus or minus the square root of 20 over 2. Now, at this point, I want to see if I can simplify what's in my square root. My factors of 20 are 4 times 5. And the square root of 4 is going to simplify down to a nice 2 on the outside. So I've got 2 times the square root of 5. And then I'm going to break that up. So negative 4 divided by 2, that's going to leave me with a negative 2. Plus 2 root 5 divided by 2, my 2's are going to cancel out here. So I'm just left with the root 5. And then the other solution is when I subtract root 5. Okay. Go ahead, and you've got 4 different equations to solve. These ones are for you. What are your solutions going to be to these four absolute value equations? Okay. If you have any questions about any of these problems, you did not get one of them correct, star it, and that way you'll know which problems to come back to on Monday when we're going over some of these problems. Now I'm going to show you kind of just a nice graphical check. So when you've got solutions to your absolute value equation, you can always check this graphically. So if I went back to this equation, the absolute value of x plus 4 equals 5x minus 2. If I want to solve that graphically, I can use my graphing calculator, setting my y1 equal to the absolute value of x plus 4, and my y2 equal to 5x minus 2. If I'm graphing two lines, just as a reminder, I'm looking for where these two lines intersect. So you can take out the Delta Math calculator if you would like to use the graphing feature. I'm going to be using the graphing calculator on my screen. So for y1, I'm going to type in the absolute value. To access that on your calculator, you're going to go to Math, and then go over to Noon, and it's the first thing that shows up, absolute value. So the absolute value of x plus 4, absolute value x plus 4. And then my y2 is 5x minus 2. When I graph that in my standard window, I'll be able to see at least one intersection. Maybe there's another one going on up at the top. So as I'm looking at this, this was the solution that I've already actually graphed this, or I've already solved for this equation, and I've found two different roots. So it's kind of weird that on my graph there's only one intersection. Let's see which one it is. So I'm going to go to Calc and down to Intersect and pick a point on the first curve, on the second curve. And I get that 1.5, x equals 1.5, so that's my 3/2 solution, is where they intersect. But there's nothing going on at -1/3, so that would be somewhere over here. They're not anywhere close to each other. What that means is that -1/3 is actually an extraneous root, so it is not a real solution that'll work out. And so your graph is actually a really good way to check to see if you have any extraneous roots. Let's go ahead and just look at the graph of this second equation that we solved, see if there are any extraneous roots. So in your Delta Math calculator or on Desmos, whichever you prefer, go ahead and graph these two pieces. So you're going to set y1 equal to the absolute value of x squared plus 4x minus 3, and y2 equal to 2. I'll do the same on my calculator. So when you graph these two lines, here's my y equals 2, here's my absolute value, you'll notice that they intersect at 4 different points, which means that there are 4 solutions to this equation. So all 4 of these solutions, -5, 1, -2 plus root 5, -2 minus root 5, all 4 of these are solutions. Go ahead and go back to these 4U questions. I want you to test and see, are there any extraneous solutions to these problems? Use your calculator, whichever calculator you prefer. You can use Desmos or you could use Delta Math, and check for any extraneous solutions. I'll ask you to identify or select all extraneous solutions for each of these problems. That's the end of the video for tonight. Make sure that you understand, or make sure you identify what you do not understand about this video, so on Monday you can ask questions.